Hello everyone. Today in this video we are going to talk about force on a current carrying conductor in a magnetic field. After this video you should be able to explain the cause of the force on the conductor and use Fleming's left hand rule to find the direction of force. So let's understand the force on a current carrying conductor through an activity. So out here I have taken one conductor which is hanged with the help of two wires, and we have one horseshoe magnet to produce a magnetic field, and out here the conductor is connected with a cell. So when the circuit is switched on, the current flows through the conductor and the conductor gets deflected in one direction, and when the circuit is switched off, the conductor comes back to the same position. And when the direction of current is changed, the direction of force also changes. When the direction of magnetic field is changed by interchanging the north and south pole, the direction of force also changes. As you can see, the deflection is in this direction. When we change the direction of magnetic field, the deflection will be in opposite direction. So the conclusion of the activity is a current carrying conductor experiences a force in a magnetic field, and the direction of force is reversed when the direction of current is reversed, and the direction of force can also be reversed by reversing the direction of magnetic field. Now let's see a video on force on a current carrying conductor. Now this is the activity. You can pause and copy. So the cause of force is the magnetic field produced by the conductor. So when current flows through a conductor, the magnetic field is produced around the conductor. So conductor also act as a magnet. So when we bring two magnets together, so there will be force between them. So similarly, there will be a force on current carrying conductor because of the magnetic field. Now to find the direction of magnetic field, we make use of Fleming's left hand rule. And this rule says, if we stretch three fingers of our left hand, that is thumb, index finger and the middle finger, mutually perpendicular to each other, and if index finger shows the direction of magnetic field, the middle finger shows the direction of current, then thumb shows the direction of force on a current carrying conductor. And the meaning of mutually perpendicular is that the angle between this any two fingers is 90 degrees. So you can see the angle between thumb and the index finger is 90 degree. The angle between thumb and the middle finger is also 90 degree. The angle between these two is also 90 degree. So they all are perpendicular to each other. So now let's understand the left hand rule using this diagram. So out here you can see magnetic field is going from north to south, and current is flowing in this conductor in this direction. So if you keep your left hand in such a way that index finger shows the direction of magnetic field and middle finger shows the direction of current, then the thumb will show the direction of force. So that means this conductor will move in upward direction due to the force due to the magnetic field. So now let's take more example. So in this rod, current is flowing in this direction, so we have to find the direction of force. So magnetic field is in downward direction. So this is Fleming's left hand rule. So first I'll try to show the direction of magnetic field with the index finger. So in order to do that, I have to rotate my hand in downward direction. So now you can see the index finger is showing the magnetic field, and middle finger is also showing the current. Then the direction of force is towards the right, so the conductor will move towards the right. So similarly in this picture, current is going in this direction, magnetic field is in downward direction. So this is Fleming's left hand rule. So I'll rotate my hand in such a way that index finger shows the direction of magnetic field, that is in downward direction, north to south, and middle finger is showing the direction of current. Then the thumb will show the direction of force. So direction of force is towards the left, so the conductor will move towards the left. So now in this picture you have to find the direction of force. So this is Fleming's left hand rule, and out here magnetic field is from north to south, and the index finger is showing the direction of magnetic field, but the current is into the plane of the paper, but out here the current is in downward direction. So I'll rotate my hand keeping the index finger in same position, so current is going in inward direction. So you can see force is in downward direction. So I'll just put the arrow and write F for force. So using Fleming's left hand rule, the direction of force is in downward direction. So similarly in this picture, this is the Fleming's left hand rule, and the magnetic field is in downward direction, north to south. So I'll rotate my hand in downward direction, but out here you can see current is going towards the right, but out here middle finger is showing towards the left. So I'll rotate my hand keeping the index finger in the same position. So you can see I have rotated in this direction. So now index finger is showing magnetic field, middle finger is showing current, so thumb will show the direction of force. So that means force is towards the plane of the paper. So in order to indicate something going into the plane, we use cross. So using Fleming's left hand rule, the force is into the plane of paper. So I'm writing out here the plane of paper because we'll solve this in paper. So actually it is going into the screen. So you can try this question using the Fleming's left hand rule. Out here also you have to find the direction of force. So P means magnetic field, I means current. So out here magnetic field is coming out of the screen and current is going in downward direction. So you can use Fleming's left hand rule for all the diagrams. And out here the current is not given, an electron is moving towards my right and magnetic field is going in downward direction. So we have to find the force on this electron. So we know the direction of current is same as the direction of flow of positive charge and opposite to the flow of negative charge. So current flows in the direction of positive charge and current flows in the opposite direction of negative charge. So out here negative charge is going towards the right, that means current is going towards the left. Now I have got current, I have got magnetic field, so I have to use the Fleming's left hand rule. This is the Fleming's left hand rule, and now I'll show the magnetic field using the index finger, which is going downward. So I'll rotate my hand like this, and you can see the middle finger is showing the current, so the force is out of the plane of the paper. So to show something coming out of the plane, I'll use a dot, so force is coming out. So using Fleming's left hand rule, the direction of force is out of the plane of the paper. So similarly you can try this question. For this diagram current will be towards the right, and for this current will be in downward direction, for this current will be in towards the left, and out here current will be in upward direction. This is the different question. In this question you have to find the direction of magnetic field. Negative charge is going towards the left, that means current is going towards the right. Now this is the Fleming's left hand rule. So first I'll point the current. This time we don't have magnetic field, so I'll point the current. So I'll rotate my hand in such a way that middle finger shows the direction of current. So I'll rotate it this way. So now the middle finger is showing the direction of current. Now the force is in downward direction, but the thumb is pointing in upward direction. So now again I'll rotate my hand in such a way that the thumb goes downward, but I'll not change the position of this middle finger. So I'll just rotate in this direction. So you can see. So now current is going in this direction, force is coming in downward direction. Now the magnetic field is coming out of the plane. So and magnetic field is coming out of the plane of the paper. So similarly you can try these questions. So you have to find the direction of magnetic field. current is going in this direction, force is in downward direction. Out here current is going into the plane of the screen and force is towards the right. Out here current is going in this direction and force is coming out of the plane. So similarly you can try all the questions. So now let's summarize the video. So a current carrying conductor experiences a force in a magnetic field, and the direction of force can be changed by changing the direction of current or by changing the direction of magnetic field. The direction of force can be found out by using Fleming's left hand rule. And in Fleming's left hand rule, the index finger shows the direction of magnetic field, the middle finger shows the direction of current, and thumb shows the direction of force. So this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.